In Java 17, HashMap is a part of the java.util package and works on the principles of a hash table. Below is an explanation of its internal working, focusing on its structure, key components, and changes in recent Java versions, up to Java 17. First, structure of HashMap. HashMap is implemented using an array of buckets and a linked list or binary tree at each bucket to handle collisions. The key components are node K, V. Each entry in a HashMap is represented as a node with key of the entry. Value associated with the key. Hash code of the key. Next, reference to the next node for chaining in case of hash collision. This is the representation of HashMap in Java code. Here it shows hash code of the key, value in reference to next node in the bucket, a constructor using all these. 2. Working of HashMap. The primary operations of HashMap are put, get, and remove. Put with K key and V value. The put method inserts a key value pair into the HashMap. Here's how it works. Calculate hash code. A hash code for the key is computed using key.hashcode and then further refined to reduce collisions. This is the code to calculate hash code. This ensures better distribution of hash values across buckets. Determine bucket index. The bucket index is calculated using the shown Java code. Herein is the length of the array. Insert into the bucket. If the bucket is empty, a new node is inserted. If the bucket already contains nodes, collision occurs. Java 17 first checks if the keys are equal using equals. If the key exists, update the value. If not, traverse the list or tree and add the node at the end. If the number of nodes in the bucket exceeds the Treeify threshold, default 8, the linked list is converted into a binary search tree, TreeNode. This hybrid approach improves performance from O of n to O of log n in case of frequent collisions. B. Get object key. The get method retrieves a value based on the provided key. Calculate hash. Similar to put, the hash for the key is computed. Locate the bucket. The bucket index is determined. Search in the bucket. If a TreeNode structure exists, it performs a binary search. Otherwise, it performs a linear search through the linked list to find the matching key using equals. C. Remove object key. The remove method works similarly to get, compute the hash and locate the bucket. Search for the node using the key dot equals method. Remove the node. If the node is part of a linked list, adjust the pointers. If it is part of a tree, remove it while maintaining the binary tree structure. 3. Rehashing and load factor. Load factor. HashMap uses a load factor, default 0.75, to determine when to resize the table. The load factor is the ratio of the number of entries to the table size. Rehashing. When the number of entries exceeds the threshold, capacity and a load factor, the table is resized to double its current size, and all entries are rehashed into the new table. Rehashing involves recomputing the bucket index for all entries, which can be expensive but ensures better performance in the long term. 4. Bucket implementation, linked list versus tree. Linked list. By default, entries in a bucket are stored as a linked list. TreeNode. If the number of nodes in a bucket exceeds Treeify threshold 8, the linked list is transformed into a red-black tree. This optimizes lookup time from ON to O log n. If the number of nodes falls below an Treeify threshold 6, the tree is converted back to a linked list. 5. Null keys and values. HashMap allows one null key and multiple null values. The null key is always stored in bucket 0. 6. Performance improvements in Java 8+. Java 8 introduced the tree-based optimization to handle collisions, which remains the same in Java 17. Before Java 8, buckets only used linked lists, which could degrade performance in cases of hash collisions. 7. Summary of key points. HashMap uses hashing to store key value pairs. It resolves collisions using a combination of linked lists and red-black trees. Tree conversion happens when the number of nodes in a bucket exceeds 8. Rehashing occurs when the load factor threshold is breached. It allows a single null key and multiple null values. Java 8 and later optimizations, including Java 17, ensure better performance for high collision scenarios.